Let's now talk about the one-to-one property for exponents. Exponential functions are always increasing or always decreasing. As a result, the graphs pass the horizontal line test. So what does this mean? Maybe you recall back from chapter 1 when we studied the horizontal line test and one-to-one functions. If a function is one-to-one, that means that the function does have an inverse. Well, we'll talk a lot more about this in the next section of the chapter. This also means that the one-to-one property can be used to solve simple exponential equations. So what is the one-to-one property? For a is greater than 0 and a does not equal 1, a to the x power equals a to the y if and only if, that's what IFF stands for, if and only if x is equal to y. In other words, two exponential quantities with the same base are equal to each other if and only if their exponents are equal. Notice two exponential quantities with the exact same base are equal if and only if their exponents are equal to each other. And hopefully that's a little bit intuitive. Hopefully that makes sense. Well, we can use this property to help us in solving some of our exponential equations. So again, always important to be able to identify what type of equation you are trying to solve. What makes this an exponential equation other than the fact that it says exponential equation? Well, notice where your variable is located. The variable is going to be located in the exponent. All right? And we are trying to solve an equation, which means we need to solve for x. Solve the exponential equation using the one-to-one property. Well, the one-to-one property works if I have two exponential quantities with the same base. Notice on the left-hand side, I have an exponential quantity with a base of 2. Is it possible to rewrite 16 with a base of 2? Well, let's see. What's 2 times 2 is 4, times 2 is 8, times 2 is 16. That means 16 is the same thing as 2 to the 4th power. Now that I have two exponential quantities equal to each other with the exact same base, that means that the exponents must be equal. In other words, x minus 3 must be equal to 4. Now we have set up a very basic algebraic equation that we can solve by adding 3 to both sides of the equation and giving us our final answer of x is equal to 7. Let's try another one. So here we have 1/5 raised to the x plus 1 is equal to 125. All right, one thing that should jump out at you is this fraction here. Now, I don't know about you guys, but I would prefer to deal not with fractions. So how can we rewrite 1/5 so it is no longer a fraction? Well, I can use properties of exponents and rewrite 1/5 as 5 to the negative 1 power. Recall that negative exponents give us reciprocal quantities. All right, 5 to the negative 1 is the same thing as 1/5. So that gets rid of the fraction. And now I have an exponential quantity with a base of 5 on the left. Can we rewrite 125 as a base of 5? Well, 5 times 5 is 25, times 5 again gives us 125. So 125 is the exact same thing as 5 to the 3rd power. Also notice over here on the left-hand side, we have an exponent being raised to an exponent. Our properties of exponents tell us that when we have exponents raised to exponents, we multiply them. This gives us 5 to the negative x minus 1, when I distribute that power in, multiply our exponents, is equal to 5 to the 3rd power. Now that we have two exponential quantities with the same base set equal to each other, okay, we know that the exponents must be equal as well. In other words, negative x minus 1 must be equal to 3. To solve this equation now, we add 1 to both sides and divide by negative 1, giving us x is equal to negative 4, our final solution. All right, let's take a look at one more. Ooh, this is a good one. We have e to the x squared times e to the 6th power is equal to e to the 5th power raised to the x. In this case, we're going to have to use a couple different properties of exponents. Again, think back to Algebra 2. I can't use the one-to-one property yet because notice that I have two exponential quantities on the left-hand side. And the one-to-one property only works if I have one exponential quantity on each side. But can we combine these somehow? Here we are multiplying exponential quantities of like bases. Our base is in e. What do we do with our exponents? Well, we add them. When we multiply exponential quantities with like bases, we add the exponents. In other words, this would be e raised to the x squared plus 6. Over here on the right-hand side of the equation, I have an exponent raised to another exponent. When we have exponents raised to exponents, we multiply them. This gives us e to the x squared plus 6 is equal to e to the 5x. Now that I have an exponential quantity on the left-hand side and an exponential quantity on the right-hand side, both with the base of e, I know that the powers, the exponents, must be equal. In other words, x squared plus 6 is equal to 5x. So what type of equation did we just generate? Well, this is a quadratic, and we can't forget about how to solve quadratic equations. To solve quadratic equations, we set them equal to 0 and we factor. In other words, x squared minus 5x plus 6 is equal to 0. This factors into x minus 2 times x minus 3 is equal to 0. And setting each of our individual factors equal to 0 gives us our final answers, in this case, two of them, x equals 2 and x equals 3. All right, so there is the one-to-one property. Two exponential quantities with the same base are equal to each other if and only if their exponents are also equal.